Okay, so I'm throwing in this one, which is a little bit out of sync with the rest of the videos thematically, but I want to leave as much of the screen blank as possible for you to see how we're going to solve these sets of problems using equations. Remember that we can visualize information in three ways. We can use equations, we can use graphs, and we can use tables. I want to show you how we can find equilibrium when we're not given necessarily a graph or a table, but when we're given an equation in the shape of a line. So for these next couple slides, next couple images, I will have my video off. So just as a reminder, when we're given information in tabular form, when we want to calculate equilibrium, we just find the equilibrium, we find the price, which sets the quantity demanded equal to the quantity supplied. And then we know that both of these then are going to be our equilibrium quantity. So quantity D equals quantity S equals quantity star, and this is our P star. Now it's similarly easy to solve for equilibrium with a graph where there are actual values for quantity and price. And we just see at what price do supply and demand intersect, at what price are quantity demanded equal to quantity supplied equal to Q star, which in this case is 300. And we see that P star, the price which sets quantity demand equal to quantity supplied, is also 300.
Okay, so we can use equations to represent the same information that's given to us in tables or with graphs. So hopefully many of you have taken algebra before and are familiar with the equation for a line, which is just going to be given by y equals mx plus b, where b is going to be our intercept, in this case 500 for our equation for demand, 100 for our equation for supply, and y is going to be the variable on the vertical axis, in this case price. X is going to be our variable on the horizontal axis, in this case quantity, and m is the slope of our line. So how quickly is price changing as quantity changes, our rise over our run variable. So we can plug in each of these values into this y equals mx plus b type equation. So we get something looking more like P equals mq plus b. So in this case, we know that price is going to be given. We assume it's the same. So we know that price is equal to m multiplied by q. In this case, we'll say either the quantity supplied or the quantity demanded. Let's consider quantity supplied, plus the intercept for that term, which in this case would be 100. Now, let's just assume that the slope of that line is 1. So we'll have P equals 1 times quantity supplied plus 100, which is going to equal P equals QS plus 100. Okay, so we can do the same thing for our demand equation. We'll have P is equal to M multiplied by QD plus 500. And in this case, let's say that the slope of this line, we're just going to assume that it's -3. So it's downward sloping. We know it's negative. And so we have -3 QD plus 500. Okay, so how can we solve this information, use this information to solve for equilibrium? Well, just like in tabular form, we know that at equilibrium, our Q star is going to equal the quantity demanded is going to equal the quantity supplied. And the price of each are going to be equal as well. So we know that we can either set the prices equal to each other. So either this equation is equal to that equation, to this equation, or we can rearrange and solve each of these equations for QS and then set QS equal to QD. So we would have something looking like QS is equal to P minus 100 and three QD is equal to 500 minus P, which we can simplify to QD is equal to 500 over 3 minus 1/3 P. And we can then set QD equal to QS. So let me just block off some of this slide here, and we can use the first equation to solve for equilibrium price. Actually, we'll do that on the next slide. So solved on next slide. Okay. Okay, so let's rewrite the equations from the previous slide here so we can use them to solve this problem. So we have P is equal to QS plus 100 and P is equal to negative 3 QD plus 500. We know that at equilibrium, QS is equal to QD is equal to Q star. So, and we know that P star is equal to P star. So let's set P equal to P and plug in our equations here, keeping in mind that QS is going to equal QD, so we're just going to simplify that to be Q. So we'll have Q plus 100 is equal to negative 3Q plus 500. And we can add 3Q to each side. And we get 4Q plus 100 is equal to 500. We can subtract 100 from both sides. We get 4Q is equal to 400. We divide by 4. We get Q is equal to 100. So our equilibrium quantity here is going to be 100. And then to solve for price, all we have to do is plug this into either one of our equations. So either into our quantity supplied or our quantity demanded. Both will give us the same answer. And if we do that, we see that P is equal to 100 plus 100. So P star is going to be equal to 200. So given information in an equation form such that we have price as the y variable and it's given to us in equations that look like this, which are similar to having this equation up here, then we can solve that to find our equilibrium price and our equilibrium quantity. I'm now going to show you on the next slide how you get the exact same answer if the information is arranged in a slightly different way. The key point here is that we're always going to have two unknowns. We're going to have our unknown equilibrium quantity, our unknown equilibrium price, and we're always going to have two equations, our supply equation and our demand equation. And the simple rule of algebra is always you can solve for one unknown, one variable for one equation. So since we have two unknowns, we have two equations, we can always solve this no matter how the information is presented. So instead of given the equations that we had on the previous slide, you may be given equations that look like QD is equal to 500 over 3 minus 1/3 P, and QS is equal to P minus 100. So once again, we have two equations here and here, and two unknowns being our equilibrium quantity and price. So we can we know that at equilibrium, QD is equal to QS is equal to Q star. And so we can set our equilibrium quantities equal to each other, and we have 500 over 3 minus 1/3 P is equal to P minus 100. And we can add 1/3 P to each side, so plus 1/3 P plus 1/3 P. We have 500 over 3 equals 4/3 P minus 100. We can then add 100 to both sides. And we get, that's the same thing as 300 over 3. So we have 800 over 3 is equal to 4/3 P. I'm just going to come up over here with that equation. And we can multiply both sides by 3. So we'll say multiply by 3, multiply by 3. We get 800 is going to be equal to 4P. We divide both sides by 4. 200 is equal to P. So this is the exact same equilibrium price that we had on the previous slide when we solved for this equation, solved for this equilibrium using those other equations. And we can similarly plug this back into either of our other equations, either of our equilibrium quantity demand or quantity supplied equations. And let's just plug it into the easier one here. So we know that, here we go, QS equals Q star equals P minus 100 equals 200 minus 100 equals 100. So Q star equals 100, which is the exact same answer that we got on the previous slide. So anytime that you have two equations and two unknowns, you can solve for both of those unknown variables. You want to think of this graph with price on the vertical axis and quantity on the horizontal axis as the B variable being your intercept and your Y variable being your price. However, if it's given to you in this form instead, then obviously your intercepts are going to be different, because we're now thinking of quantity as the independent variable, or as the dependent variable. So just be familiar with what you're being asked to solve. Be aware of what you're being asked to solve, but you always want to set quantity equal to quantity and price equal to price. And if you do that, then you're going to find your equilibrium price and your equilibrium quantity. That's really all the tricks there are to this. So let me know if you have any other questions about these problems, but basically it should just be algebra solving for two variables. So I hope this has been helpful. If you have any other questions, feel free to email me, and hope you all are doing well.